saya Wan. Ini adalah video sambungan daripada video lepas. Segmen ni saya nak terangkan tentang lapisan OSI. Lapisan OSI ada 7, iaitu lapisan fizikal, yang kedua lapisan bautan data, yang ketiga lapisan rangkaian, keempat lapisan pengangkutan, yang kelima lapisan sesi, yang keenam lapisan persembahan, dan yang terakhir adalah lapisan aplikasi. Saya menerangkan tentang lapisan rangkaian. Terima kasih.
Seven layers build up the Open Systems Interconnection, or OSI model. Let's take the flow of data and represent it with a train system. Sending a file or clicking a link in your computer ignites a flow of information. The first layer to receive the command is the application layer. The application layer serves as the window for the users and application processes to access the network services. This layer contains a variety of commonly needed functions like resource sharing and device redirection. Data are packed and ready to take on a long journey. After the data is read, the next layer, or the presentation layer, formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station. It then translates the common format to a format known to the application layer at the receiving station. The presentation layer also encrypts control information into the data, in this case, the train, to be read by the next layers. This layer allows session establishment, maintenance, and termination, which allow two application processes on different machines to establish, use, and terminate a connection, called a session. This session support, which performs the functions that allow these processes to communicate over the network, performing security, name recognition, logging, and so on. This layer remembers everyone who passes by. After another journey, the data pass through a layer of security and validity, the transport layer. This layer scans and makes sure the data is reliable and valid, and that the messages are delivered error-free, and then broken down or acknowledged into segments. A security firewall is usually in action at this layer. Data that do not pass will be rejected or destroyed. And because the session layer before remembers the data that gets through, data are retransmitted when there is no connection acknowledgement. This is the safe haven of the data whenever data packets are lost. Down to another layer is the network layer. Here, the segments are encapsulated into packets. Routing takes place in this layer, where the path the packets will take is determined. Packet filtering routers and firewalls sometimes take place in this layer. The lower the firewall in the layer is, the more secure the network. An additional responsibility of the network layer is that it adds a source and destination Internet Protocol or IP address to the segments. The next layer is the data link layer. The packets are turned into frames for the specific networks. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmissions over the link. A switch in networking takes place in this layer, where packets are read of its control information and then encoded with the Media Access Control or MAC address. The MAC address contains 12 hexadecimal digits and prevents collision in the same media. Finally, the physical layer transforms the frames into bits, and then sent over the network via physical hardware or media, in this case, the Ethernet. Data are logically arranged and encoded before they get sent to a physical media to another computer, and is then received by another computer's physical layer. Some data or information in the upper layers are destined to be sent through the Internet, a vast interconnection of information and data. Either way, the data sent will then be received by the 7 layers of another computer, from the physical layer, which encodes the bits, back to the data link layer, where the bits become frames and is transferred error-free, to the network layer, where frames turn back into packets and then sent to the upper layers, into the transport layer, where validation and firewalls take place, sent up to the session layer, where connections called sessions are maintained or terminated, back to the presentation layer, where the data are turned back into a format that can be read by the presentation layer, and finally, sent and presented to the user via the application layer, where you will be provided with your request or command.
Function. The network layer provides the means of transferring variable length data packets to a destination host via one or more networks. Within the service layering semantics of the OSI network architecture, the network layer responds to service requests from the transport layer and issues service requests to the data link layer. Functions of the internet layer include connectionless communication, host addressing, message forwarding. Protocol EGP, Exterior Gateway Protocol, EIGRP, Exchange Interior Gateway Routing Protocol, DVMRP,
Distant Vector Multicast Routing Protocol, ICMP, Internet Control Message Protocol, PIMDM, Protocol Independent Multicast Dense Mode. EGP Exterior Gateway Protocol. Exterior Gateway Protocol (EGP) is a protocol for exchanging routing information between two neighbor gateway hosts, each with its own router in a network of autonomous systems. EGP is commonly used between hosts on the Internet to exchange routing table information. The routing table contains a list of known routers, the addresses they can reach, and a cost metric associated with the path to each router so that the best available router is chosen. Each router pulls its neighbor at intervals between 120 to 480 seconds, and the neighbor responds by sending its complete routing table. Exchange Interior Gateway Routing Protocol (EIGRP) is an advanced distant vector routing protocol that is used on a computer network for automating routing, decision, and configuration. The protocol was designed by Cisco Systems as a proprietary protocol, available only on Cisco routers. Partial functionality of EIGRP was converted to an open standard in 2013 and was published with informational status as RFC 7868 in 2016. The Distance Vector Multicast Routing Protocol (DVMRP), defined in RFC 1075, is a routing protocol used to share information between routers to facilitate the transportation of IP multicast packets among networks. It formed the basis of the Internet historic multicast backbone. The Internet Control Message Protocol (ICMP) is a supporting protocol in the Internet Protocol suite. It is used by network devices, including routers, to send error messages and operational information indicating, for example, that a requested service is not available or that a host or router could not be reached. Protocol Independent Multicast (PIM) is a family of multicast routing protocols for Internet Protocol (IP) network that provide one-to-many and many-to-many distribution of data over a LAN, WAN, or the Internet. It is termed protocol independent because PIM does not include its own topology discovery mechanism, but instead use routing information supplied by other routing protocols. PIM is not dependent on a specific unicast routing protocol. It can make use of any unicast routing protocol in use on the Internet. PIM does not build its own routing tables. PIM uses the unicast routing table for reverse path forwarding.